So two of the most common types of graph that you could get asked to draw in your exam are exponential and reciprocal graphs. Now, exponential is probably a word you've heard before. You talk quite a lot about things growing exponentially. In biology, perhaps at GCSE, you might have talked about the way that bacteria divide, and that is an exponential division. The easiest way to remember it is how I was taught it at A level, which is with an E with a tail. And that it grows with a very, very rapid rate. Reciprocal graphs are slightly harder, but we know what the reciprocal is. So we know that the -1 in the expression x to the power of -1 is the reciprocal function, and that actually looks like 1 over x, and that's the graph we're going to be drawing. So, y equals 3 to the power of x. Now this is actually an exponential graph. So let's have a look at what's happening. When x is 0, we have got that y is 3 to the power of 0. Well, anything to the power of 0 is just 1. So we know that when x is 0, y is 1. So we're going to hit the y-axis there. Then when x is 1, y is 3. 3 to the power of 1 is 3. So when x is 1, y is 3. When x is 2, y is 3 squared, which is 9. So we've got 3, 9. And you can start to see this curve go. At the moment it looks a bit like a straight line, but obviously my scale's a bit funny. And then 3 to the power of 3 is 27, which actually, in terms of my little graph, is way off the scale. It's sort of shooting up in that direction. So we've got this really now beginning to become quite a steep line. What happens the other side of that y-axis then? Well, 3 to the power of -1, we know is a reciprocal. We know that that's 1/3. So at x is -1, the height of the graph is 1/3. And then at x is -2, we've got 3 to the power of -2, which is 1 over 3 squared, which is 1 over 9. So it's even smaller. So actually what we're doing, this is 3 to the power of -3, which is 1 over 27. Then we've got 1 over 81 and 1 over, I'm not even sure, work it out. So as we tend to infinity, as x gets smaller in the infinite direction, so we're going infinitely small, we're actually going to tend to 0. So y is going to get closer and closer and closer to 0. But it's never going to hit 0. It's never going to hit 0 because we're never going to find a value of x that produces 0. You can try it if you like, but even x is 0 produces a 1. So there's no value of x that is going to give us a 0 there. So we actually have what we call an asymptote along that line. We represent it by a dashed line, and asymptote is one of the weirdest, can't even spell it now. Asymptote. One of the weirdest spelt words I think I've ever seen before in my life, and I think it took me about 4 years to work out the spelling to it. Asymptotes are part of the graphs. They're not optional extras, they're not added details and flourishes you can just add. They are part of the graph. So if you are sketching this graph, which I haven't finished yet, there we go. If you're sketching this graph, the asymptotes have to go in, which means if you're transforming graphs or you're moving them or you're doing anything with them, asymptote lines have to go in, and we represent them by dashed lines. Okay, reciprocal graph. We're just taking a really standard y equals 1 over x. So no flourishes, no fancy 3s or squares or anything like that. We're just going to take 1 over x. Okay, so in the same way that we planned the last one, let's have a look at what happens as we increase x. So we're going to think about what's happening as we get bigger and bigger x's. So let's start at x is 1. So y is 1 over x. X is 1, so that's y is 1. Then when x is 2, we've got a half there. When x is 3, we've got a third. When x is 4, we've got a quarter. So in terms of our graph, we're going to plot 1, 1, then 2, half, 3, quarter, x to the 4. Now, as we tend to infinity, so as we get infinitely large, that fraction is going to get infinitely small. It's going to become 1 over the really big number that you've chosen here. But again, it's never going to be 0. And the reason for that is, no matter how big an x value you choose, you're still going to have an x value. So you're never actually going to get to 0, although you'll get very, very, very close to it. So that suggests to me that certainly along this side we've got an asymptote line. Okay, now I'm interested in what happens after 1 but before 0. So at 1 we know that we've got y value of 1. What happens when we've got a half? So halfway between 1 on our graph and the origin. We've got here, what's going on here is we are going to have 1 over 1/2, which is the same as 2. So at a half on our graph, our y value, the height of our graph, is 2. What's happening at, say, a quarter, so halfway between a half and 0 now? Well, our answer is going to be 4. So again, we're shooting up. We've almost got like an exponential graph in reverse in this case. It's not quite, they're not reverse functions of each other or anything like that, but it's got that same appearance. And again, you can ask yourself, as we get closer and closer and closer to 0, what's happening to y? Well, y will get larger and larger and larger and larger and larger and larger and larger. But we know for definite that we cannot have, x cannot be 0. Because if x was 0, we would get the fraction 1 over 0 as our y value, which of course we know can't exist, and you can try it in your calculator will have a strop on you. Okay, so we've gotten our large x's. We've then dealt with our x's between 1 and 0. What about our negative x's? So let's start with negative 1. Well, 1 divided by negative 1 is negative 1. 1 divided by negative 2 is negative 1/2. 1 divided by negative 3 is negative 1/3. So actually what we've got going on here is sort of the shape in reverse. So the same arguments hold, but just in the negative. As we go towards a sort of negative infinity, our fractions are going to get increasingly small because x is getting increasingly large. But between negative 1 and 0, so if we look at negative 1/2, we're going to get -2, negative 1/4, we're going to get -4, negative 1/8, we're going to get -8. As we're going closer and closer and closer to 0, our y answer is going to get increasingly large in the negative direction. So we end up with this kind of funny shaped, almost like X on its side graph. But again, we've discovered points that we know this graph definitely can't cross. It's going to be the X and Y axes, so we must put in our asymptotes. You need to get really good at drawing these graphs because when you get onto transforming them, the shapes need to be in your head instantly, but you also need to be thinking about why these are working. So get onto your graph transformations and don't forget to practice these.